this is Arnoud, WizBiz.com, and welcome to this special hands-on video with all the necessary information and building instructions to build your own classic electronics modules. I'll show you how to build functional replicas of these classical modules. These are classic Fischer Technique electronic modules, affectionately called Silberlinge because of the aluminum appearance of the faceplate. There were several of these electronic modules issued by Fischer Technique in the late 1970s and the early 1980s. These are by no means all of them. Around 11 volts of DC power was connected via a rectifier module, and relay modules were used to drive lamps or motors. Both of these functions, both at the beginning and the end of the chain of Silberlingen, can be solved in a more modern way these days. I personally like to provide power to them with a net adapter module and replace the modules by my own driver outputs or H-bridge modules. Nevertheless, these modules are still very much in demand. If you search the internet, you can still find the originals as well. However, they have become collector's items today. And that's a shame if you just want to quickly build an electronic principle with it. Just like many other people, I also try to rebuild these vintage modules. I tried to stick as close to the originals as I could, so unlike many others, I've also mimicked the metal strips at the sides of the casing to loop through the power supply. So if you slide the modules together like this, you can simply loop through the power supply using the original Fischer Technique red clip. I've always thought that was a great feature of the original modules. I have received a lot of questions about my self-built modules, so eventually I've made these building kits available. And in this video tutorial I will show you how I built the modules. Most actions are the same for each module. The mounting of the metal strips and the sockets of the Fischer Technique connectors will have to be done for each type of module. But for example, a potentiometer is only used in the differential amplifier and in the monoflop module. Okay, let's get started and search for the four metal strips. There are two long strips and two short strips. The long ones go vertically in the case and the two short ones go horizontally in the casing. But we're gonna start with the long strips. They should go through the small slots in the sides of the casing. Just like this. Wait a minute, I feel there is a sharp side and a smooth side to the strip, so let's turn the sharp side inside, and then it goes between the little bridge on the bottom of the case. Try to center the strip so it sticks out about the same length on each side. Let me check if I did a good job here. Hang on. We have the length about this on one side and it's almost the same on the other side, so I think I did a great job already with this. Okay, hold that in place a bit and bend it right around the rim in one go. We like the metal strip to be bent as tightly as possible, so we might press it a little bit with a screwdriver. That will make a slightly sharper bend here. And when we do the other one as well, we already have one strip finished. Okay, so there it is. Okay, but there was another long strip to be inserted vertically. Let's speed things a little bit up so you don't have to wait too long. You see, I can work very fast if I want. And almost finished. Yeah, press it a little bit harder and we're done. Well, we're done with the vertical ones, that is. So next up are the two horizontal metal strips, and they cross over a little bridge at the bottom of the casing, so they don't make contact. The other side that doesn't go over the bridge makes some contact here. So eventually we get this. The four strips are inserted and they make contact at two places. That's the plus and the minus, and the other side goes over the bridge and is isolated from the other strip. But to be sure it makes contact, we have to solder those junctions. Be careful there. Don't solder too long or too hot, because then of course the plastic of the bottom of the case could melt. So try to solder as swift as possible. And when you feel it will take you longer than possible, you might consider preparing it with a little bit with some sandpaper or polishing wheel on your multi-tool. But as you can see, it's also possible without these preparations. The backside is also very good and completely clean, no burn marks, no melt spots. I think it is okay. So here's our tray with all the components and the circuit board. The circuit board has a silkscreen printing on one side. This is also the side where all the components are sitting, and the whole PCB eventually goes upside down into the case like this. And here on the front side of the circuit board we have to insert and solder the sockets that might be used to plug in the Fischer Technique plugs through the front plate in a moment. Let me come back to that in a moment. First we have to solder on all the components. All the values are printed on the circuit board. This makes it clear where the different components should go, but of course double check that with the corresponding component layout document. That can be downloaded as a PDF document from the website. Just follow the link in the description of this video. So with that description as a reference, you should be able to figure out which component goes where. It's best to start with the lowest flat-lying axial parts like the resistors or diodes. For example, this is a 82 ohm resistor. Let's see where it's gonna go. It has to be inserted over there. So that's a matter of banding and plugging it in on the side where it's shown on the silk screen. Let's do this with the other parts as well. What do we have here? This is a 10 kilo ohm resistor. Let's bend it and search where it goes. Over there. Okay. As been said, the component list should show you every place of each component. Let's see what we else have here. This is a 330 ohms resistor. Well, that goes over there. So it's best to insert and solder all the axial low components first, and then the PCB can still lie easily on its back to solder it. And these little holes over here, by the way, of course, the transistors go. Most of the kits only have one kind of transistor, so you can't go wrong here. Only the differential amp or the Grundbaustein has two types of transistors, but from the description it should be clear which one goes where. I'll take it out for now because I'm going to do all the resistors and diodes first. Okay, so I have some components soldered already, and now these metal wires need to be cut off, of course. Don't throw those wires away for now. Save the longest and most useful ends because you might need them. We will need at least two of them to make the final connection from the PCB to the metal strips of the case in a moment. These two on the sides. And we might need another three more if we have a module with a potentiometer, because there are two modules in the kits series that have a potentiometer to be fixed to the PCB. Okay, finished with the resistors now. These little symbols indicate a electrolytic capacitor needs to be soldered there. But before we do those, let's finish all the flat laying components like the resistors first. And when that's all done, we can go further with the elements that are standing up, like these resistors. Look at the symbol over here on the PCB, on the silk screen. They have to go resistors there, but they're standing up, so they're mounted in a different way. Just fold one of the wires alongside the component and insert it standing up like so. Of course you can turn it 180 degrees, but you get the idea. These are the standing resistors, standing up resistors. There are a lot of these, and I think all of the resistors of the Grundbaustein, the differential amplifier are standing up, but in this mono flop we're making at this moment, there are only 2 of the components standing up. But on second thoughts, let me first show you how to insert the ceramic capacitors by folding them a little bit wider so they fit the footprint that's on the PCB. Print, by the way, that's kept a little wider so you can use a variety of ceramic or metal film capacitors there, but just fold them a little wider so they fit the holes and just solder them in. So we're only left with the 2 standing resistors, and after that we can do the transistors. But first let's fold these standing resistor wires so we can insert them in their standing position. And next up will be the transistors. Just align the flat side of the transistor with the flat side on the silk screen and insert the right transistors. Most of the modules, by the way, have only 1 type of transistor, so you can't go wrong. But for instance, the Grundbaustein has 2 types of transistors, so take care there. Alright, eventually the PCB will be placed behind the front panel on these small legs here, and of course we want the LED to stick out nicely here. Let's see, where's the LED in my components? Okay, always pay attention to the flat side of the LED. This is the flat side of the LED. That's the cathode or the minus, and that has to go into the little square aisle that you see here. There is a round and a square aisle, and it goes into the square. And of course, it has to be mounted on the other side of the PCB. Take a look there. That's the square and where the cathode goes. Okay, so to find the correct mounting depth of this LED, place the circuit board behind the lid of the box for a moment, like this. And now you can gently push the LED through the hole so that it comes through at the front. Yeah, look at that. Very nice. Just fix it with some solder on the component sides. Let's do that right away. And once that's fixed, you see it comes through the front plate really nice. And all that's left is clipping off those wires. Maybe this is a good moment to mount the electrolytic capacitors. Take care of minus and plus there. Of course, the small wire is the cathode again. It's the minus. Goes in like this. And yeah, take care of the polarity of those things. The black printing on the PCB, that is where the minus have to go. So the short wire. Just mount them in and solder them in. We need some wires again. That is, if your kit contains a potentiometer, like the monoflop I'm building here. The potentiometer slides over the 3 wires from the component side of the PCB, like this. I hope I can get it done. There are small holes in the contacts there. And there is one thing about soldering it on. First of all, take care it doesn't short circuit with components that are underneath, like this resistor. And another thing is, it's quite important to solder these wires as short as possible, because just like with the LED, things should not get too hot. I have to admit I already had one broken potentiometer where the thin carbon traces coming from the contacts were burned through because I just soldered it too hot and too long. So take care there. So if you tighten the screw, solder the 3 iron wires and clip the ends, it should look something like this. Now this is a good time to add 2 more wires to your PCB, the 2 wires that will connect the power supply in a moment, and that we're going to solder on the metal strips in the case. Okay, so the next step is to place these little sockets for the Fischer Technique connectors, for the Fischer Technique plugs to slide into. However, notice these pins are not quite symmetrical. So the hole for the Fischer Technique plug is not exactly straight behind the pin that we're going to solder. In order to get behind the front in the right way later on, it's important that we always place the slot in these buses to the inside point, oriented to the inside of the PCB. So it's important, you notice there is this little slit, a small opening in the buses, and when we're going to mount these pins, the little slit is always be pointing to the middle of the PCB. In this way they can be soldered. Just put a little tin on the outside, let it flow for a while. You might force it to an upright position a bit with your tweezers. Okay, let's talk a little bit more about the flip-flop and the differential amp, the Grundbaustein, and those buses for Fischer Technique plugs. You might notice when you're building these kits that there are also sockets to be placed in the middle at the top and in the middle at the bottom row. These are the rarely used X inputs for the flip-flop and the number 1 and 8 inputs of the Grundbaustein. As you can see, the PCB already takes into account that these sockets are not quite symmetrical. The pad is placed a little bit lower on the PCB. We already saw that the little slit in the sockets have to be positioned towards the middle for the left and the right row, the vertical rows. But for these positions, the small slit should be facing outwards. So in the top row it should face to the top, and in the bottom row it should face downwards. In most cases you also do well to position the socket slightly angled outwards right away. There might be newer versions of the board in the future in which this has been corrected, because the pad is actually a bit off grid, is a bit too low. So you can compensate that a little bit. Don't worry, everything will look great from the outside and the hole will actually be perfectly behind the hole in the front. Okay, so after you've soldered all these sockets and replaced the lid, you might see that not all sockets are exactly aligned in the first place. Let's correct that later on. At this moment I'm very curious whether the module works, because basically we can start testing it right now. I've made a small setup here with my own power module, and if we connect the ground and the plus like this, then basically we already have a good setup for testing the monoflop. I have a little switch here that's just going to switch between plus and minus 9 volts. If the switch is not pressed, the signal is high, and then it's considered inactive because the Silberlingen use negative logic. The front plate will be my little reference. Switching signal goes to the pulse input of the module, the monoflop. And then we just need to connect these buses for a moment to make a short time timer. So, well, basically it's ready to go now. So let's take a look when I put the power on here. I already saw a little flash. So at least we've got the LED connected around, right? Let's go ahead and give it a pulse. Let me set the potentiometer about in the middle and give it a pulse. Yeah. Well, that's indeed pretty short, but good news because it works. Our module works. So then we're almost there now. Here we have our tested PCB with the 2 wires soldered on it that finally have to be soldered to the metal strips that provide the power supply. And we can slide it into the tray, into the case like this. And you can see it's actually sitting right there. All that's left now is to solder these power points to the metal strips. After soldering, cut the wires as short as possible, because we don't want to have the lid bump into it when we put it back on. Let's take a look. Yeah, I've cut it short enough so it can fit quite snugly there. So finally, let's take a look at the alignment of the sockets and see if they're fitting nicely behind the holes in the front. These sockets over here are quite good, quite nicely behind the openings in the front. Here it is actually okay too, but these over here might need a little alignment. Hope you can see. Those are not perfectly centered behind the hole, so what I'm going to do is this. I'm just going to reposition these little sockets a little bit. Yep, like so. Let's take a look which direction they have to go. And let me get my tweezers. By reheating the solder a little bit, you can fine-tune the position quite easily. And after they're aligned perfectly, just add a little solder. Do not try to move too much before the solder is well solidified again. So let's fast forward this a little bit and you'll find out that it's really quite easy to reposition those small sockets. There we go, add a little solder and look at this. I think it's perfectly aligned now. And the lid can be closed completely all the way around, also on the sides, so we're ready to screw it on. I always clean up the screw holes with a screwdriver first. The small screws to close the lid might find their way in the holes much easier then. And this is our final product with the rotary knob pushed on the potentiometer. So with the module completely finished, let's test it again. For this I have this test setup that allows me to quickly couple the module and test it. The time I'll set it to short, I'll set the rotary knob somewhere in the middle and I'll simulate the switch for a moment. It's hanging from the minus now, it goes to the plus for a moment and then back to the minus again, and that's my pulse. So from the plus to the minus, and there we have our pulse. Okay folks, this brings us more or less to the end of our video assembly guide. I hope that your module also works well and that you will enjoy it very much in your Fischer Technique projects. The power supply is looped through in a familiar way, controls and design also blend in well, so this is a nice drop-in replacement of a vintage Silberling. Remember, for more information follow the link in the description. So for now, I can only conclude with a heartfelt happy hacking!